Hello. In this video, I'm going to be talking about periodic trends. So these are trends within the periodic table that help us to make educated guesses about what kind of reactions might occur. And so when you're starting into reactions, having some kind of basic gut feeling for which atom is going to be the most nucleophilic or which atom is going to be the most acidic will help you to kind of think through the possibilities of what might be happening in a reaction. And so we're going to do that with a periodic table. So I'll draw us one up. And as organic chemists, we really only care about this first row over here: boron, carbon, nitrogen, oxygen, fluorine. And we know that the noble gases sit here, but they don't react, and so we're not particularly interested in them either. Okay, we're going to be focused right in this range. And so the four trends that I'm going to talk about can be remembered with the mnemonic BEAN. B, E, A, N. Where B stands for basicity, E stands for electronegativity, A stands for acidity, and N stands for nucleophilicity. So I'm going to start explaining it starting with E. I know that's out of order, but it makes the most sense chemically to start with that. So electronegativity is the measure of ability to pull electrons towards a particular atom when it's in a covalent bond. So if two atoms are bound together with two electrons, if one of them is more electronegative than the other, then the more electronegative atom is going to have a tendency to pull the electrons towards itself. This is basically a description of how happy an atom is having electron density around it, how badly it wants to pull electrons towards itself, okay, and kind of be negatively charged. And so if we think about the trend for that, it goes in this direction, with fluorine being the most electronegative atom in the periodic table. So the trend is to the right and up, which means that fluorine is more electronegative than oxygen, which is more electronegative than nitrogen, and more electronegative than carbon. And so as we move in this direction, okay, we're moving away from this desire to have electrons around it. Okay? And also as we move up, so fluorine is most electronegative. As you go down the periodic table, the rest of the halogens are less electronegative. And so this concept of electronegativity is then part of kind of explaining the rest of these trends. So we'll do basicity next. Basicity, the trend for basicity goes like this. It moves up and to the left, so that carbon is more more basic than nitrogen or oxygen. Now that makes sense if we think about the reaction that's happening. So what that means is that what basicity means is that if I have CH3 minus, and I add it to a proton source, and I allow it to then act like a base, it will become CH4 and no longer be negatively charged. A similar idea is if I have OH minus, and I add a proton source, oxygen then gets protonated and becomes water. Okay, no longer charged. And so from this trend, we could say that carbon is more basic than oxygen, which means that carbon is going to react faster to get a proton and not be negatively charged. It's going to react faster than an oxygen atom to become protonated and lose that negative charge. And that makes sense if we think about the electronegativities. So oxygen is more electronegative than carbon. Oxygen is more interested in having electron density around it. And so when they're sitting like this in their negatively charged forms, oxygen is more stable. it's more electronegative, it's more stable being negatively charged. The carbon is less stable being negatively charged, okay? It's less electronegative, and so it's going to react faster than, it's going to be more basic than, something that's more electronegative, because it does not want to be negatively charged. It wants to act like a base, get a proton, and lose that negative charge. And so that's the trend for basicity. It's not only to the left, but it's also up. Okay, and so we find out for a different reason that as we go down the rows of the periodic table, things become more stable holding negative charges. Okay, as we go down a row, the atoms have more electrons, and so they have something called expanded octets. They're holding their electrons a little further away. Okay, they're more polarizable, and so they become more stable holding negative charges. Okay, so as we go down, we get more stable holding a negative charge. More stable means less basic, because it means it's more safe or more stable to hold a negative charge. And so the basicity trend is not only to the left, it's also up the periodic table. Now in comparison to that, we have the trend for acidity. And we find that the trend for acidity is in the opposite direction. And we know this from acid-base chemistry. Things that are strong bases are weak acids, and vice versa. Things that are strong acids are weak bases. And if we think about this as a reaction, okay, what this is saying is that something that is more acidic is happier to give up its negative or give up a proton and become negatively charged. So let's think about that as an example. H2O plus a random base is going to become OH minus. And if I stick with this example and I say methane plus a random base is going to become CH3 minus. And so if I want to know which one's more acidic, well, it's going to be the one that's more stable holding the negative charge, because when it has to act like an acid and give up a proton, it becomes negatively charged. And so as I move towards things that are more electronegative and down the periodic table, I'm getting to atoms that are happier being negatively charged and so are more likely to give up a proton and become negatively charged themselves. Okay, they're better acids because they're more stable when they're negatively charged. Now the last trend is nucleophilicity. And the nucleophilicity trend is like this. So nucleophiles are a little bit different from bases, okay? And so you're going to get into this more once you start reactions. But right now what I want you to keep in mind is that the nucleophilicity is not the same as basicity. Typically, things that are good bases are also good nucleophiles and vice versa, but that's not always the case, and it's a different kind of reaction. And so the nucleophilicity trend moves down and to the left. So something that's going to act like a nucleophile is going to go and attack something, okay? It can attack a proton and act like a base. It's something that has electron density, okay? And so we're going to be moving away from things that have electronegativity towards things that are less stable being negatively charged, okay? Because they want to use that electron density to go do something. They're not stable holding the electron density themselves. They want to do something with it. And so that's the trend away from electronegativity. But unlike just basicity, the trend also strengthens as we go down the periodic table, not up. Okay, and that's because of the basic difference between something that's being a base and being a nucleophile. As we go down the periodic table and we get to those expanded octets and we get to larger atoms that are holding their electrons farther away from the nucleus, we get to something that's more polarizable. The electron cloud is softer, and so that means that it can react like a nucleophile better. That will make more sense to you once you start talking about reactions. Okay? Once you get into an SN2 reaction and you start thinking about what's actually happening with an electron cloud as a reaction proceeds. But just for now, I want you to remember that the trend is down and to the left. Okay? It's not exactly the same as basicity, but the trend away from electronegativity is the same. Okay, but as we go down, things become larger, softer, more polarizable, and that nucleophilicity then increases. Okay, so these are the 4 trends that I want you to remember. They really are going to help you for just the rest of your chemistry, organic 1 and 2. You're going to come into situations where you need to think about a reaction and being able to kind of comfortably and off the top of your head think through these trends is going to be very helpful. So I would spend some time now and really make sure that you understand them. Thank you for watching the video, and I hope it helps.